Okay, so here's another walkthrough on S1 January IAL paper 2025. So I'm gonna just hit the timer again to reset, and now the timer is hit. So we're gonna walk through this whole paper. I've never seen the paper before again, so let's do it. Number one, which is a long one here. Jen has one fair four-sided red die and one fair four-sided blue die. The red die has sides numbered 1 to blah blah blah, and then you read the information. This is discrete random variable. Okay. So question A. Write down the name of distribution R. Okay, so the discrete random variable R represents score from one row of the red die and B from one row of the blue die, because they're all fair dies, right? So this is discrete uniform distribution. That means the probability for each variable is the same. Yeah, it's a fair die. And then find PR less than 3. So PR less than 3. So we would have, this is R being red, so we have P of R equals 1 plus P of R equals 2. So just the 1 and the 2, less than 3. And that would be, because there are 4 possibilities, so one of each of them would be 1 over 4. So this is 1 over 4 plus 1 over 4. So that's 1 over 2, right? So that's not hard. C, write down the value of ER. So expected value of red. Okay. Well, we can do 1 times 1 over 4, the red one, yeah, plus 2 times 1 over 4 plus 3 times 1 over 4 plus 4 times 1 over 4. Yeah, that's the expected value. So that's 1 over 4 plus 2 over 4 plus 3 over 4 plus 4 over 4. And that's 3, 6, 10 over 4, which is 2.5, right? Yep. So that's I, expected value of B. Again, it's the same thing, right? So I'm just going to do 1 over 4 here and then add up all the values because they have the same probability. Like that. So we have 4, 9, 16. 16 over 4 is 4, yeah? That's it. Write down the, D now, not C. D. Showing your working, find var B. Right, so var B would be the E of B squared minus the EB squared, like that. Yeah? We haven't got the expected value of B squared, so we got to find that first. And that would just be a quarter again, because each of them has a probability of a quarter. And then the B squared for each one would be 1 squared plus 3 squared plus 5 squared plus 7 squared. That's the first term, E of B squared, and then minus expected value of B. We got it already, 4 here, so we do 4 squared. Okay, so I'm going to use a calculator here. So a quarter times 1 squared plus 9 plus 25 plus 49. That's the first term, minus 16, the second term. So I got 5 here. So that's var B being 5. E. Jen rolls each die once. Find probability that PR plus B less than 5. So PR plus B less than equal 5 would come from, if we do R and B, so it's got to be probability of less than 5. Okay, let's see. So it's either 1. Okay, so if R equals 1, then B equals 3, right? Or R equals 1 and B equals 1. That's also possible. If R equals 2, then B should be 3 because it can also be 5. If R equals, we have another one, 2, B equals 1. Yeah, that's also possible. 2 and 1. And that's it for 2. Now let's have a look at 3 now. R equals 3, then B should be equal to 1. Do we have something else? 3, 3? No, that's it. And then if R equals 4, then B is equal to 1. And that's it, right? Yeah, that's everything. Okay, so we have 6 cases here. So it's got to be R equals 1. That's 1/4 times 1/4. So all of them is a quarter times a quarter, right? Because they are both discrete uniform, right? So that means we can just add them all up. So we count 1, 2, 3, 4, 5, 6. So 6, and each of them is 1/4 times 1/4. Yeah? Let me check. Yeah, all right. I think so. So this is 6/16, which is 3/8, right? Okay. F, find R squared less than B. Okay, R squared less than B. Okay, so R squared, we have 1, 4, 9, 16. If you just, think about all of them there. And B, we have, again, I'm just going to write 1, 3, 5, 7. So this would be probability of R squared less than B would be probability of R equals 1 less than B. So we have R. Okay, I'm going to do this. If R is 1, so if R is 1, then B can be 3, 5, 7. If R is 4, then B can be, if R is not 4, is 2. Yeah, because 2 squared is 4. So if R is 2, B can be 5 and 7, right? If R is 9, B cannot be anything. B will be less. So we want R squared less than B. All right, so it's just 1 and 4 because 9 is not less than anything. And that's it, right? So how many cases here? So we have 5 cases, right? So that is P of R squared less than B would be 5 cases where each is also 1/4 times 1/4. All right, so this is 1, 2, 3, 4, 5. Yeah, just making sure. All right. Right. Okay. And that is 5/16. G now. The random variable D is defined as the magnitude of difference between the score of red die and the score of... Oh, my timer is just doing that again. Between the score of red die and the score of blue die, the table below shows the cumulative distribution function of D. Right. Okay. So showing your working, find the value of P. Okay, so, well, that's fine, right? So this is cumulative distribution. Okay. I mean, all right, so we can do, for the table, we can do, wait, hang on. 0, 1, 2, 3, 4, 5, 6. Okay. And we can do P of D equals D, right? Just gonna move 0 here. Yeah, I'm just gonna make a table, actually. So this is 1 over 8. If we subtract 1 over 8 from 3 over 8, we get 2 over 8 here. Yeah. Subtract. And then we subtract 9 over 16 from... Hang on. I don't think we need to do this, right? Let me check. Let me think about that. P minus... So if we subtract the 3 over 8, if we minus 3 over 8 by 1 over 8, we get the 1. So if we minus 3 over 8 by 1 over 8, we get 2 over 8, which is the second one here. So that means... Yeah, I guess we have to, Hang on. We can do this trick. So P plus 15 over 16 equals 1, right? Yeah, because they have to add up to 1, right? So it's like you are almost at the last value now. So this value right here, whatever it is, wait, hang on. Okay, I think I need to do this. So, okay, P of D equals 5 would be equal to 15 over 16 minus P. All right, let's do slow. And then P of D equals 6 is 1 minus 15 over 16, which is 1 over 16. Yeah? Okay, I think this is going to work. So that means if I add f of 5, yeah, just the last value here, to... Wait, I need to get D equal 4 as well. Hang on, let me just try that. Okay, so P of D equals 4 here. Yeah, it's going to be P minus 3 over 4. Yeah, let's do that. Let's delete all of this. Put this up here. So like, so if you add up all the things from 0 to 4, you get up to P, right? And then, interesting. Okay, you know what? I think I'm gonna maybe find all of them. But if we add them up, we're not gonna get that. Wait, hang on. Oh, the random variable D is defined as the magnitude of difference between the score on the red die and the score on the blue die. Okay, I see. Okay. 1 over 16. Wait, I know now. Okay. So f of 4 equals P, which is equal to f of 3 plus P of D equals 3, right? Yeah? Wait, hang on, let me refine that again. So let's say if you take f of d equals 1, f of d equals 1, which is f1, is from f of d equals 0 plus p of d equals 1, right? So that means f of 5 is f of 4 plus p of d equals 4, right? Oh no, this is 5, sorry, yeah. So we know that f of 4 is p. D of 5 we already got to be that. That doesn't help. All right. What about we try f of 4 is going to be f of 3 plus p of d equals 4. Let's try f of 3 instead. Equals 3 over 4 equals f of 2 plus p of Okay, I think I'm gonna just have to go with the table here. Sorry, I've been taking too long. Yeah, probability. So that's 1 over 8. That's subtract, we get 2 over 8. Subtract that, we get 9 over 16 minus 3 over 8. Oh, that's horrible. 3 over 16. 3 minus 2, 3 over 4 minus all right, you know what? I think I'm gonna skip this one first. I'm sorry. Yeah, okay. So let's just go to the second question. My brain is not braining for the first question. All right, maybe later I can manage, right? So excuse me for that. Again, this is a live walkthrough, so anything can happen. Okay, so this number 2 here, yeah? So number 2, A. Find the range of these observations. So as part of an investigation, Bobby collects a sample of 47 observations X. The result as shown in the following stem and leaf diagram where A is a constant. Find the range. So the range is just maximum minus minimum, right? That's the range. Okay, so the maximum, so we gotta look at the key there. 3/2 means 0.32. Okay, so maximum is 0.87 down here, yeah? 0.87, yeah, I'm just checking, yeah. Minus, the minimum one is 0.21, all right? So that's 0.66. That's the range. B, find the value of the median of these observations. So median for discrete data would just be will be at n plus 1 over 2. So n is the total number of observations in this case. So 47 plus 1 over 2, that would be 48 over 2, that would be 24, right? 24 is the 24th observation. So if we just count from the start here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, I can just add these, right? 15, so 16, 24, 16, 17, 18, 19, 20, 21, 22, 23, 24. So that's 0.48, right? So the median equals 0.48 is the 24th observation there. Okay, let me make sure again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Okay, so B is 0.48. C, given that the interquartile range of these observations is 0.31, find the value of A. So A is around the upper quartile, I would say. So the lower quartile would be, so the Q1 TH is at n plus 1 over 4, which is 48 over 4, which is at the 12th observation. And Q3 would be at 48 times 3 over 4. That would be at 12 times 3, 36 observation. So 12, this is 5, 6, 7, 8, 9, 10, 11, 12. So that's 0.35. So Q1 equals 0.35. And Q3 would be equal to A, I guess, yeah? So we count from this 36, so 47, 47, 46, 45, 44, 43, 2, 1, 0, 39, 38, 37, 36, yeah. Just to make sure. So interquartile range equals Q3 minus Q1. That means we put interquartile range as 0.13, Q3 as A, Q1 as 0.35. So that means A equals 0.66. Just solving that equation gives you that. Okay, so that's C. D. I just got to make up for the time I lost in the first question, really. Bobby calculates the following statistic from these observations, show that the standard deviation of these observations is that. So standard deviation, SD, is just the mean of squares, which is that guy, minus the square of mean, which is just the mean. You found the means first and then square it. Okay, so, oh, and don't forget the square root, right? So we already have the sum of x squared. Yeah. Okay. And n would be, yeah, I think I'm just gonna 47 here because it's still the same data. Minus sigma x is 23.72 over 47, and then we square this. And then we square root all that. So I'm just gonna put in the calculator already, but let me record the calculator screen first. Here we go, the calculator. So fraction 13.4228 divided by 47. And then I gotta be careful with putting the thing in here. Minus the mean, which is 23.72 over 47 as well, but we gotta square that. And then that would be 0.17575 dot dot dot. Putting the three significant figures, it's that as required. Bobby now collects 18 more observations. Why? From the sample investigate from the same investigation. Okay. So using all 65 observations, yeah, 18 more. The sample mean is 0.502. Okay. And the sample standard deviation is that. Show that sigma y is that. Okay, so y bar is equal to sigma y over n, right? If you want to find the mean of anything, that's the formula. So that means sigma y is just y bar times n, which is y bar was given as a sample mean 0.502 times n, which is the new quantity now. So 0.502 times 65. Yeah, we get, wait, what? Sigma y? That's not right. Hang on. Oh, sorry. This is the 18 more observation. Right. Okay, sorry. This is not total. Okay. So we're going to use the combined mean formula. So the combined mean, let's say x bar new would be equal to x bar 1 n1, just the first group of data, plus x bar 2 n2 divided by the total n. Yeah. So the first mean and the sum. So this is basically, you can take this as the sum of x, right? It's just the first group, right? So we're going to take the sum of x there, 23. Don't need to do all the calculation again. Plus, okay, so the 18 observation has the mean of, wait, no. Yeah, okay. So all this again is the second group, which is the sum of y, right? So this is the second group, yeah? So I'm just going to do that. Divided by the total is 65, and the new mean is 0.5202. We're going to solve for that equation. So y bar would be, sigma y would be just 65 times 0.502 minus 23.72. All right, so there you go. As required. So that's EI. Showing your working, calculate sigma y squared. Well, okay. So, okay, so we got the new standard deviation, right? So the standard deviation, nu, is equal to, is the sum of all squares of the data, right? So at first we got sum of sigma x squared. Now we have to add the extra, the sum of sigma y squared. That is the new sum of squares, and divided by 65 in this case, right? And then we got a minus the new mean. Yeah, so the new mean is 0.520 squared. Okay, and we're given that the standard deviation, has now become 0.204. So we just plug everything in and solve for the equation. I'm just gonna do that already, if you don't mind. Okay. Now we also know that the sum of x squared is 13.4228. Yeah, we're given that in the question. So that means to solve for sigma y squared in this case is just 0.204 plus this thing 0.5202 squared, and then multiply 65, and then a little more space down here maybe. And then we're gonna subtract this by the sigma x squared, the 13.4228. Okay, so the answer to that would be our answer here. 502 squared bracket times 65 minus 13.4228. So that is 16.22. I'm just gonna put like that. Okay, so that's my working there, 3 marks. So yeah, standard. Wait, what? I forgot to do the square root. Sorry. So hang on. Which one did I miss? I gotta do this first, right? And then that would have been fine, I think. Yeah. So just square this guy. Okay, so it should be 5 instead. Sorry. I'm just gonna keep the answer like that. Yeah. I think I'm happy with everything here. Just checking. Yeah, it's okay. That makes sense. Not too much because the sigma x squared is more. Next, question 3. There you go. It's a long tree diagram there. So A, we need to complete the tree diagram below to illustrate this information. So a factory makes rugs and blankets from wool and cotton and polyester. 30% of the items are rugs, and 70% of the items are made of blankets. Okay, so we have then we have 0.7 here. Sorry, 0.3, and then 0.7 here, right? And then 60% of the rugs are made of wool. 60%, so 0.6 here. 30% of the blankets are made of wool. 35% of the blanket, 10% of the rugs are made of cotton. 20% of the blankets are made of cotton. Okay. The rest of the rugs and the blankets are made from polyester. Okay. So this is 0.3. This is 0.55, so 0.45. All right. So that's done for question A, I hope. Yeah, if I didn't make any silly mistake there, of course. Just subtract them, B, first find the probability that the item selected is not made of wool. Not made of wool. So would be rug, cotton, polyester, and blanket, cotton, polyester. So that would be BI probability not wool would be 0.3 times 0.1 times 0.3, yeah, 0.3 times 0.1, sorry, and then plus 0.3 times 0.3. That's for the rug, not wool. And then we add 0.7 times 0.2 plus 0.7 times 0.45. Yeah, so that's everything that is not wool. Okay, so we're just gonna put that in a calculator. 0.3, I'm just gonna do times 0.1 plus 0.3 there, just to make it a little faster. And then 0.7 times 0.2 plus 0.45, yeah? Okay. Yeah, I think I'm happy with that. Just checking everything. So the answer is 0.575 for BI. BII, given that this item is not made of wool, find a probability that it is a blanket. Okay, so not made of wool we already found, so we're going to use this probability. So this is probability of blanket given that it is not wool. Okay? All right, so it's just probability of blanket. So not wool blanket. It's just the one that is not wool, and it's also a blanket, it's not a rug, and divided by probability of not wool, anything that is not wool, right? So we already know that the denominator is 0.575, but the numerator, we need to find the probability that not wool and blanket. Not wool, but blanket. Blanket that is not wool. It's just the bottom two here. So we can take these things here. Yeah, the blanket that is not wool. Okay. All right, so it's just 0.7 times 0.2 plus 0.45, right? That thing there. Okay, so 0.7 times 0.2 plus 0.45. And then down here we have 0.575, right? So that's 0.791. That's it. Just going to give 3 decimal places in general. Okay. Yeah, we are fine with that. Number 4. Going to do A here maybe. A manufacturer of pet food gives samples of 3 new flavors of cat food, A, B, C, to each 100 customers who own 1 cat. These customers are surveyed to find out whether or not their cats like each flavor in the following results. Okay, so we just need to complete the Venn diagram basically, and it doesn't seem to have any other diagram, so I'm going to use this given diagram here. Usually the technique for this S1 Venn diagram is to fill from the most overlapped area, which is the middle here. So it says 12 cats like all 3. So we put 12 there, simply. Right? So we use this information, so we tick. And then what? 20 cats like both B and C, yeah? So both B and C here, but we got to subtract 12 from 22, so we got 10 here. So these two add up to 22, which is B and C, right? Using the same method, A and C, right? So A and C, 20. So these two add up to get 20. So this is 8. Put it in the middle here, 8. And then A and B here, 19. So this must be 7 to add up to 19, yeah, for A and B. So we have used these. And now we do C, 50. So down here must add up to 50. This is 8 plus 12, 20. 20 plus 10 is 30. So this is 20. So that C is 50, yeah. A is 40, so this is 15, 27, 27, subtract 40, we get 13. Right? Just double checking. Yep. And then B, 45, so this is 19, 29, 29, we get 16. because 29 at 16, we get 45, I believe. Yeah, okay. Right, so that's 16, so that's done. B, determine whether or not a cat liking flavor A is independent of it liking flavor C. Well, so we just prove that if we find PA times PC, yeah, it's going to be equal to, so PA times PC is 40 times 50 divided by, so 40 divided by 100, this is 100, right? They all add up to, wait, hang on. I forgot to make sure that this, let's see. Yeah, okay, so let's do A40, just checking, plus 16 plus 10 plus 20. So A plus 16, A is totally here, 16, 10, and 20. That is 86, so this must be 14. Almost forgot that. Okay. Okay, so PA is 40 over 100 times PC is 50 over 100. That's 0.4 times 0.5 is 0.2, right? And then PA intersect B. PA intersect B is basically A and C, so it's 20 over 100, right? Which is 0.2. So because PA times PC equals PA intersect C, therefore, cat liking A is independent of it liking C. I'm just repeating the question there, basically, just to be safe. We got to give it context, mostly for a statistic paper. C, one of these 100 cats is chosen at random. Find the probability that it likes only one of the three flavors. Only likes one of the three. So we are looking at the area of these three numbers, which is 13 plus 16 plus 20. So 13 plus 16 plus 20 divided by 100. That would be it. Yeah? And that is 29, 49, 0.49. Yeah? Only one of the three. That's it. And then II here, given that it likes flavor C. So this is given C. The probability that it also likes flavor B. Okay, so B given C then. So that means we want PB intersect C over PC. Right? So B intersects C. Or we can just, within the C, yeah, you can look at in the C circle, what is in B. So there are 22 here in B and C, so that's 22, just divided by totally in C. So 22 divided by 50, that's it. Which is 0.44 if you do the math there. Okay, so let me check again. 22 divided by C, which is 50, yeah. So 0.44 is the answer. Okay, next to the question 5. All right, so A. Using standardization and showing you're working, find the probability that in one randomly selected day during the summer more than... Okay, so I'm going to need a table here. Let me just get the formula sheet first. Okay, get the formula sheet here then. All right. Okay, just in case. This is normal distribution, right? Okay, so AI, find the probability. So we want to find P. This is S, not X. They give you S there. S more than, yeah, X greater than 640. Okay. All right. So we want to find the Z score first. So Z score, or the Z value, is 640 minus 700 divided by the standard deviation, which is 50. So 640 minus 700 divided divided by 50. That is minus 1.2. So if you look in the bell curve, I normally suggest students to not memorize any formula, but just visualize the bell curve rather than memorizing anything. So the mean is 700, right? But your value is here. But you want greater than this. So which is to the right of that. Knowing that the bell curve has symmetrical property, you can reflect it to this value, which is the value of z being not 1.2 rather than minus 1.2. And then you want its area less than this. It's the same. So you are finding p of z less than 1.2 in the table, right? So you just look at the big table and get this probability here. Yeah, that would be equal to the one we want. So 1.2. Set of 1.2 is just 0.8849, right? Yeah, 8849. There. Okay. And then the second one, 700 kilograms of the glass, correct to nearest, is deposited at recycling center. 700 kilogram of the glass corrected to nearest 50. I see. Okay, so this is basically we want just the probability of S being in the range of this. So it's 750 and 650, right? So correct to nearest 50 is when you go higher than 50. Wait, hang on. Correct to the nearest 50. No, it's 725, right? You got to divide that by 2 first and then add and subtract from the central value, which is 700. So this is, yeah. So 675, okay? Nearest 50. Yeah, that's the only way. Okay, let me check that actually. Correct to nearest 50. Could you go higher than that? So yeah, I think this is right. So you divide by 2 first and add. One is by adding, the other one is by subtracting. Yeah. Okay. Yeah. All right. So well, we can just find one of the z value because look, this is still symmetrical because from 700 there, because 700 is the mean, right? So that means if we go by 25 on the right, it's the same as go to the left by 25. So the probability of this is the same as the probability, I do the other one further away, sorry. It's the same. So this is the same value here, right? So we just want, maybe we just find only this bit. And the way to find this bit is to find this whole bit first, right? We need to find this whole bit first. And we just do that by finding the z value of that. So 725 minus 700 divided by with the standard deviation. So this comes to 0.5. And P of Z less than 0.5 is 0.6915, right? Okay, let me check again. Yeah. And then if you subtract, 0.5 from this, you're going to get this half. So probability of that whole thing, we know that we can do that by do 2 times that minus 0.5. Because one of this is just this bit. We got to multiply by 2, yeah? Okay, so that's equal 2 times brackets 0.6915 minus 0.5. So that's 0.383, right? So that's done. Okay, next, part B now. The weight of glass WK deposited at the recycling center the day during winter can be modeled by another normal distribution. Given that, find 2 equations in terms of mu and lambda, mu and sigma. Okay. Okay, so they give you the probability. You got to find the z value for these 2 first. but let me draw out because it makes sense to maybe draw the bell curve first. You have some value beyond which the probability is 0.06. So that's almost like at the right end. So this is maybe Z2, okay? And the value is just 680. And then you have on the left end maybe less than 599 where it's 30%, yeah? So 599 is here. And we have in the middle here mean, all right? Okay, so I think we can look at the table. So let's see if we can find anything like, if you do 1 minus 0.0668, see if you find any 0.9332 here. Aha. So that's 1.5 for the Z. Okay. So, yeah. So this is P of Z less than 1.5. Is it 1.5 again? Yeah. Is going to give you 1 minus 0.0668, right? So we use Z equals 1.5 here. Now for the other one, right? The other one, you have probability of it being here 0.3. So if we reflect to the other side, let's say, it's going to be 0.3, but to the right side, we can find the Z value there and reflect it back. So you can see that if we go probability of 0.3, but to the right side, yeah, so this is basically the right tail, and Z value being 0.5244. This probability area is 0.3. Well, that means the tail that we want, which is actually on the left, would be minus. The Z value would be minus this one. Because don't forget, the bell curve has a symmetrical property, right? So that means our Z value is 0.5244. Yeah? Minus. Okay. So this one, P of Z less than minus 0.5244, was it? Yeah. Equals 0.3. All right. That means we have two equations now. So the first one, minus 0.5244 equals the x599 minus the mean divided by the sigma. So I'm just going to make it a linear equation here. 599 minus mu, equation 1. And then the other one being Z of 1.5 equals 680 minus mu over sigma. And then again, 1.5 sigma equals 680 minus mu to be the second equation. Okay, and that's it because they only want you to find equations, and the next one, of course, solve them. Yeah. Okay. So it is easier if we subtract them. So if I do 1 subtract 2 like this, I'm going to get basically 0.5244 minus, well, these two are both minus. So if you subtract this by this or minus this by this, you get minus 2.0244, right? Sigma equals, subtracting 680 from that, we get 181, right? No, 81. Okay, subtract 680 from about 600 and a bit more here. And mu will go away, so sigma will be, wait, this is minus, sorry, because sigma cannot be negative. So 81 over 2.0244. That's sigma. So that, okay. And then to find mu, I just substitute sigma into equation 2. Okay, so this is mu equals 680 minus 1.5 times that. Okay, so mu would be equal to, I put answer to this one first, then I do 680 80. Okay, minus 1.5 times answer. So I get 1619.98 blah blah blah. So therefore mu equals 619 point. I'll just do 620. Gotta be careful with rounding that. 0.0. And then sigma would be equal to 40.01. Yeah, just to the same significant figures. All right, and that's it. Gotta hurry up a bit. Number 6, guys. We still have question one to finish off after we got time, but okay. So show the product moment correlation coefficient for these data is minus 0.901. All right. So yeah. So PMCC is SXY divided by square root of SXX times SYY. Do we have everything? We have, yeah, so this would have been SWT and this SWW, STT, right? We have SWT, we have SWW, but we don't have STT. So STT is just, let's do STT down here. So STT equals, that would be sigma t squared minus sigma t squared and then over n, right? Basically, it's just the equation of variance multiplied by n, guys. Yeah? You just take variance multiplied by n, you will get this. Okay, so this is 14837 minus sigma t is 635 squared divided by n, which is how many? 30 applicants. Okay, so 14837, yeah, minus 635 squared divided by 30. That's about it. Okay, I'm just going to stop there. So PMCC would just be equal to plugging in everything. SWT is minus that divided by square root of SWW we got given, which is that number, times the STT we just found, which is that. Okay, I'm just gonna do calculator here. So minus 1648.83 divided by square root to 396.9397 times answer, because that was STT. And yeah, minus 0.9013 blah blah blah, which is minus 0.901 as required. Question B. A scatter diagram of T against W is plotted. Okay, T against W. Yeah, all right. State two features of the graph that you would expect to see given the correlation coefficient in part A. Two features. Okay, so two features means what is the kind of correlation it is. So one is a negative correlation. Negative correlation, yeah, is like it means that when W increases, when W, I'm just going to put some context here, W is test score, increases, the T, yeah, which is the kind of like the Y value, which is the time taken, decreases, right? Because it's negative correlation here. Okay, that's the first expectation. The second one is that because the PMCC is close to 1, right? As PMCC is close to 1, so the scatter, the data points are close to a straight line, right? That's how you comment. I hope that's fine. Just these two, yeah? Okay. C. Calculate the equation of the regression line. All right, so we got to find the B value first here, which is the SWT divided by the SWW, XX, yeah. So it's minus 1648.83 divided by SWW, which is 2396.97. That's the B value there. Minus 1648.83 divided by 2396.97. So that's the B value, minus 0.68788. And then the A value. So the A value can just be found by just putting that regression line equation where you have T bar and W bar instead. Yeah, I mean, I don't like memorizing formula, so I just remember like that. And then, because in the formula sheet, they would have A equals something. So this is just A equals T bar minus B W bar, right? And T bar, did we find it? It was, okay, we didn't. So 635 divided by N, which is 30, minus B, which is that guy, times W bar, so which is 839 divided by 30 as well. Just put everything in the calculator, 635 over 30. And then, well, minus time, so time plus 0.68788. Just the one we got there, times 839 over 30. So that's my A, 40.404 blah blah blah. So the regression line equation is T equals A 40 point, it does say 3 significant figure, yeah, plus, this is a minus instead, minus 0.688 W. That's the regression line equation. And D, give an interpretation of the gradient of this regression line. So we take this gradient here. So there is, this is a decrease of T value for every 1 unit increase of W. There is a decrease of 0.688. What is T again? Minute in the time taken to, context is king in S1. I mean, in statistics, right? So you got to write everything because T stands for this whole thing, the time taken to complete the task. For every one, so for every one unit increase in test score, right? It's like those people who perform well, tend to spend less time. That's what it says there. Okay, but we don't have any comment. We just comment on the actual data here, the T and the W, right? So that's it. Part E now seems long. State for each of the following whether the value would increase or decrease or stay the same. The test score W was a score out of 50. Okay. All right. The manager of the selection process now decides to double all the values of W to make them into percentage. Okay, yeah, fair enough. The manager then recalculates the product moment correlation. That shouldn't change. and the equation of regression line. Yeah, so basically it's just, let's say we have a new score being Z equals 2W, basically, right? Yeah, so it's just that. State for each of the following whether the value would increase or decrease or stay the same as a result of applying this change. The product moment correlation shouldn't change because you just do a coding here, okay? We don't need to reason, right? State, yeah, so I'm just gonna do stay the same. And here, the second one, the magnitude of the gradient of the regression line. Well, the gradient might be doubled because well, let's check actually. So is it, so we if we apply Z equals 2W here, right? So imagine that instead of W, we have we multiply this by 2, so it's a 2W instead, right, in here. So, or W is Z over 2, right? So we're going to use Z instead. Yeah. So because we do the coding, we multiply the W by 2. So that means this is Z over 2, right? So the magnitude of gradient would be slashed by half because we got to cut that. Yeah. So it would change. It would decrease. Wait, the magnitude of gradient. Yeah, okay. Yeah, because we have a negative sign here, we got to be careful. So it's the magnitude. So yeah, it does decrease. Oops. So decrease, yeah. And then the third one, the t-intercept of the regression line. All right, so if we actually do put this, wait, hang on. Yeah, the y-intercept should be the same, right? Because if we do z over 2 here, the gradient changed to half, but it doesn't affect this. It doesn't affect this, right? So there you go. No change. Okay, and I'm done with that. Number 7. I'm going to do A here. Use the linear interpolation to estimate the probability that a randomly chosen cabbage from this sample has a weight of less than 570. A farmer supplies cabbages to a local supermarket. The supermarket manager takes a random sample of 200 of these cabbages, and weight of each cabbage is recorded. The weights of the cabbage sample are summarized in the box plot. Use linear interpolation to estimate the probability. Yep. Okay. All right. So 570 grams. 570 is where? Okay, we gotta use the diagram here in this case. 570 is around here, yeah. So that's 570, no? Yeah, this is 570. So it's around here. We want the weight less than this. Now we know that this is Q2 and this is Q3. We can see that this is kind of symmetrical. Right, so that's good because we can assume then that yeah, there is no skewness here because the gaps between Q1 and Q2 equals the gap between Q2 and Q3. So it means that so you have to know that Q2 is 50th percentile and Q3 is 75th percentile. So that means in between here there is 25% of the population. Okay, that means this is how long? So it's 2 out of 10 squares. Right? So it's 2 out of 10 here. That means it's also 2 out of 10 times 25%. Yeah? Right? So it's like this. Interpolation. Because I do 570 over 550, sorry, minus 550 divided by 650 minus 550. It's just the length of this bit divided by the length of this bit. Because we want to find what is the percentage around here. Yeah. Okay, and we know that that has to be equal to the percentage x minus the 50th percentile divided by the 75th percentile minus the 50th percentile. If you find x, that would be the percentage of the population below which the weight is less than that. All right, so this is 20 over, what is that, 100 equals, this is times, this is 25, yeah, as I said earlier. So this is x equals, this is 5 here, so this is 55, yeah. So we know that less than 55%, yeah. So p of x less than, this is continuous or not? Not continuous. Well, maybe. Yeah. 55%. I'm just going to say that. Well, let's do 0.55. Okay, B. Supermarket manager takes the quartiles from this sample and now decides to classify any cabbage whose weight is at least Q3 plus blah, blah, blah as extra large. That seems like an outlier. Find the minimum weight of a cabbage that the supermarket manager would classify as extra large. Okay, so Q3, which is obviously on the box plot there, 650 plus 1.5 times Q3, which is 650 still, minus Q1, which is 450. This value equals 650 plus 1.5 times 200 in the brackets there. Okay, so that's 950. We gotta use the diagram to find out 950 there. But find the minimum weight of the cabbage that the supermarket manager would classify as extra large. Minimum weight, is it 900? This is the minimum weight. Yeah, this is it. Okay, but the actual minimum weight, yeah. So I'm just gonna wait, it's grams. All right. So the supermarket manager assumes that the weights of the cabbages supplied to the supermarket may be modeled as normal distribution. Explain whether or not the box plot support this assumption. Okay, so the assumption, this is when it's symmetrical, and we have no idea about the mean and the standard deviation, so we're not going to comment on that. But the box plot does supports, yeah, yes, because Q1, so I'm gonna, as I said earlier, Q1 minus Q2 minus Q1 equals 100. Q3 minus Q2 equals also 100. So Q2 minus Q1 equals Q3 minus Q2. Therefore, it is symmetrical. Yeah. So symmetrical is a good characteristic to be modeled as normal distribution. Next, the farmer records the weight of every cabbage harvested from a field and classifies any cabbage whose weight is more than 2 standard deviation above the mean as an outlier. Assuming that the weights of the cabbages of this field may be modeled by binomial distribution, find the probability that the randomly selected cabbage harvested from the field would be classified as an outlier using the farmer's method. Okay. Yeah. More than 2 standard deviation above the mean. So outlier is x outlier is greater than mean plus 2 standard deviation. Okay? A randomly selected cabbage. Okay, so Yeah, so this is basically, if you know the bell curve, right? Yeah, so this is the Z bell curve, all right? Normal, 0, 1 squared. So the middle is 0, and this is Z of 1, this is Z of 2, and whatever. So you have to know that these Z values, 0, 1, 2, they're from this. So if I, for example, how do I get Z of 1? It's just basically you have an X minus mu over standard deviation. That's the formula. But the X value to get Z of 1 is that you gotta have mu, let me want some space here, mu plus 1 standard deviation and minus mu divided by standard deviation. So it's like greater than the mu by 1 standard deviation. So if you cancel out, do the math here, you get 1. So that means in our case, when Z equals 2, right? When Z equals 2, that means the X value would be mu plus 2 standard deviation. And we want to find the probability that a randomly selected cabbage is an outlier. So we want to find this probability here. Okay, it's just that. Okay, an outlier there. Let me check if above the mean. Yeah. So we just want this tail right here. So we want probability of Z greater than 2. So it's just 1 minus PZ less than 2. All right, so we check the table. Z of 2 is 0.9772. That's it. Let me double check that. 9772, yeah. So 1 minus 0.9772 is 0.0228. That's it. That's the probability of an outlier. And then E. The mean weight of the cabbage harvested from the field is 560 grams, given that the cabbage with a weight of 1,000 grams is classified as an outlier by the farmer. Okay. Find the maximum possible value of standard deviation of the weights of the cabbages harvested from the field. All right, so yeah, if this is, okay, so if we take Z equals X minus mu, which is already known, 560, divided by sigma. And we know that to make it at the critical point where it's about to be an outlier, Z must be 2, right? So if it asks for the maximum possible standard deviation, right? And this is 1,000, right? This is 1,000. So I put 1,000 here. Okay. So if sigma is maximum, that means this has to be smallest. I mean, it could be more if 1,000 is more than just being a critically outlier. So let's say 1,000 is greater than that critical value. This value would have been more than 2. But because we want the maximum possible standard deviation, so we want to make this minimum. And the minimum Z value required for it to be at critical here is just 2. I mean, you could have more than 2, but 2 is the critical value. So basically just solve for sigma in this case, yeah? So sigma equals 1,000 minus 560 divided by 2, basically. Which is 220. That's large. Hang on. It's very large. Okay. Yeah. All right. Very, very large. Okay. It's just, yeah. Because 1,000 is very far from the mean. It's almost like 2 times. So that means the standard deviation is very large here. Yeah. Okay, I'm gonna take that. 220 is the answer. All right. Oh, that's it. That's done. Now we go do number 1. Yeah. I don't know why I started off badly like that. Okay, let's have a crack on question G again, because I didn't quite get this whole table thing. Random variable D is defined as the magnitude of difference between the score on the red and the blue die. Okay, the difference between the score on the red die and the blue die. How come you got a difference to be 6? Ah, yeah, right. Okay, got it. That's fine. Yeah, it probably has something to do with how you compute this thing, but yeah, gotta be from the table here. Okay. Yeah, you know what? I'm just gonna properly do the table because I was out of option there. Maybe I didn't see something. Maybe you guys can comment to help me, but I'm gonna do D 0, 1, 2, 3, 4, 5, 6. And then because if D is already given, right? But I'm gonna do P D equals D instead, yeah? Okay. Then that. So this must be 1 over 8. 3 over 8 minus 1 over 8, we get 2 over 8. And then 9 over 16 minus 3 over 8, we get, put it as a fraction, 3 over 16. Okay. 3 over 4 minus 16 over 9 over 16. Yeah, we get 1 for the 3 there. Again, fraction, 3 over 16. And then this one must be, hang on, P minus 3 over 4. This one must be 15 over 16 minus P. And of course, this one is 1 over 16 if you do 1 minus that. Now, of course, if you add these all up, you would get 1 because the P will cancel. So that's why I got stuck, because it wouldn't help. But I put it like this anyway. And I'm not sure if... So random variable D is defined as the magnitude of difference. I think we need to calculate something about this distribution. So for example, if we take P of D equals 4 here, this comes from the fact that we got, so red being 1 and blue being 5, right? Is there any other possibility? Red being 1, blue being 5, that would be a difference of 4, isn't it? Can we get any other way? If red is 1, blue is 5, yeah, that's... If red is 2, blue can't be anything. If red is 3, yeah. So red is 3 and blue is 7. Difference is 4. And then we have, that's it. Red is 4. If red is 4, then we don't have anything for blue. So yeah. So this is P of that plus P of red being 3, blue being 7. Okay? Now, to find the probability for each one, this is, yeah, because we stated earlier that this is all uniform distribution because they are fair dice. So we do just, 1 over 4 times 1 over 4 plus 1 over 4 times 1 over 4. That's it, right? So that's 1 over 8. This is 1 over 16 times 2. So we know that for that, P minus 3 over 4 is going to be 1 over 8. Okay, so P is 1 over 8 plus 3 over 4, which is... Yep, that's it. 7 over 8 or 0.75875. Yeah. So, well, I'm going to do a fraction here. But is that right? Yeah, I mean, it doesn't matter because these two will cancel anyway. But out of interest, let's check for P of D equals 5. So how you get 5? So we expect this to be what? 15 over 16 minus P, which is 7 over 8. That should be 1 over 16. So probably about, one case. So the difference is 5. The only way to get that is 1 doesn't pair up, 2 and 7. Red being 2, blue being 7. And there is no other way. So that's about right, actually. Yeah, so that would be my P. All right. Yeah, when you sort of like come back later, maybe your mind is clearer, right, to do the question. I think I'm going to call it. Let's mark the paper then. Okay, so here I have the mark scheme for S1, January 2025. Let's have a look how well I did it. Okay, number 1 was the one that was quite tricky to me. Discrete, uniform. Okay. Although I had extra word here, but that's fine. So this is 1 over 2, 2.5, 4. Variance is 5. 3 over 8 here. Wait, no, they don't have. Oh, yeah, it is 6 over 16 indeed. 5 over 16 here. Okay, so what was the P thing? 7 over 8. Nailed it. Phew. So I think other ones are fine now, hopefully. Range is 0.66, 0.48. This A is Oh, I see. The value of A, yeah. The upper quartile is 0.66. So, yeah, right. I should have known. It asked the number that to put in the stem and leaf diagram, not the actual upper quartile. I fell for that. I shouldn't have. Right. So E of the first one is that. That is 5.662. Yeah, all right. 0.3, 0.7, 613, 35245, 575. This should be right, I guess. Is that? That's 91 over 115. Yeah, about right. That's fine. I mean, they sometimes do fractions, sometimes decimal, So maybe put both of them. Yeah, these are all fine. B, yeah, independent because they are equal 0.2, and this is 0.44 or 22 over 50. Correct. A, 885 here. And then the second part, 383. This is minus, the two equations. Although I just rearranged, so this is, I think, fine. Yeah, this one is fine. This one is also fine. 1.5, yeah. And then you got these to be that and that, yeah. So they award that, so I'm fine with that. Number 6. PMCC is minus, yeah, I managed to prove this. So the two features, linear relationship. Points lie close to a straight line, yes. Yeah, as W increase, T decreases, yes. Okay. T equals 40.4 minus that, yes. Average score increased by 1 on average. Do I need that word? The time decreases by that. I mean, let's see. So for numerical interpretation, we must mention score and time. Yeah. Okay, I think I get it. E1 stay the same. Decrease stay the same. Good. All right. The last one here. 0.55. Yes. 950 grams. Yes. 0.2. 0.228. Yes. 220. Yes. So I think I lost just 1 mark, guys. 74 out of 75. Let's see how well I did compared to the other people. Okay, so this is S1, 74. Oh, so you gotta get 75 to get 100%. That's crazy. So many people did well, and that means, right? Okay, that was fine, I guess. So feedback on this, well, this one got me. I spent too long on this one. Although coming back later, I still managed to figure out. Just need a bit of maybe a different angle, right? So maybe sometimes when you look at something and then you got stuck, try come back later. But make sure that you do have time to do that, right? Otherwise, you would not make it, basically. So this one is really tricky. I would like you to maybe go back and check out how I figure out the table thing here. But otherwise, the tricks to do the discrete random variable, like the inequality and everything here for E and F, you should be aware of that too, right? So on the second question, yeah, be careful for this. I fell for this. Otherwise, it would have been 100. Yeah. And be careful with question E right here. Yeah, question E, it's a combined mean equation. So you would add up the two data sets and then divide by the total number, right? Okay, this one is fine, I guess. The blanket wool thing. This one is fine. The technique is to fill in the most middle part first here, and then progress outwards. Okay. Yeah. Normal distribution is usually fine here. I mean, if you understand the concept really well. I don't suggest you memorize anything except the Z score. The key technique here for normal distribution is that you need to be able to know how to visualize what area you want. And the other key technique is that you need to know that this is symmetrical. It's a symmetrical distribution. So I already mentioned that technique, implementing it in the question here that, when you have z of negative 1.2 here, and you want the area to the right, it is just the same as the area to the left of z being 1.2. You got to know that. So there is no need to memorize anything if you understand the fundamentals of the normal distribution. Okay? And this is the key thing. On, I think this one here. Yeah, this one, I almost got it wrong. But to the nearest 50, right? So the question says to the nearest 50 here. So you got to go from the mean or the value there by half of the 50. I mean, it would have been obvious if it's to the nearest one. So anyone would have guessed 700.5 and 699.5, right? But this is 50, so it's less obvious. At least as far as I'm concerned when I teach students. So they don't know how to deal with nearest 50 here. So you just slash that, divide that by 2, and add and subtract. You're going to get the bounds here, the new upper bound, lower bounds. And then you can find the probability accordingly. Okay, so the way I found the probability of this one is to split to one side and multiply that by 2. And here's another important one. You got the two information here where you need to link that to the z values. So one is on the left, the other one is on the right. You want to maybe go back and check how I do that one. But be careful, right? And you know how to use the tables very well between the big table and the small table. The big table, you input the z, you get the probability. The small table, you input the probability, you get the z. But sometimes you can use the probability value if you are lucky in the big tables, like you do the other way around, right? Okay, and that was it. This one, yeah, correlation, quite fine. The weird thing about this question is that it never quite does the magnitude of gradient. This is probably the first time I see in this S1 paper. So coding, how does coding affect the gradient of the regression line equation? Yeah, it's probably one of the first time I see this. Actually, the first time, honestly, right? So you gotta be careful because this is multiplying the W by 2. So if we substitute that by, because Z, I put the new score as Z, so Z equals to W, but W equals Z over 2. So it's like you're changing this to Z over W. And 1 over 2 here would multiply b, so that would slash the gradient by half, right? That's why the gradient decreases, the magnitude. And otherwise, everything else is just fine, I think. And the last one, box plot here. Yeah. Yeah, this year is more creative than the past years. Like, they asked you to find the probability in the box plot. Never quite did that before. That's quite different. And then it asks you to you know, correlate that to a normal distribution. And this one is very tricky here. This one you need to know that to standard deviation greater than the mean, what does that mean in normal distribution? Try to understand the underlying concept of normal distribution is really key to nailing S1, I would say. Because you see, how many questions were there? 3, I guess, in this paper involving normal distribution. 2 or 3 at least, right? And if you are doing S2, it's going to come up again. All right, so it's like the most important distribution, I would say. Yeah. And this farmer standard deviation thing here is quite large. That amazed me a bit, but there you go there. Yeah. Okay. So that was it. I hope that was all useful. I'll see you in the next one.